Our company brings together leading experts in the field of plasma technology and gas thermal processing of metals. Since 1996, we actively participate in solving the complex of rail wheel problems on Ukrainian railways. We have carried out long-term successful tests of heat-treated wage wheels with participation of leading specialized institutes of Ukraine. Our equipment for plasma hardening of solid-rolled and bandaged railway wheel is widely used on the railways of Ukraine, Moldova and the Baltic states. The problem of wheel and rail joint operation, their reliability and life duration, is of current interest for all railways in the world. Wage wheels and rails must withstand the specified level of load and force impact arising at interaction between them while preserving long durability. Even today, the standard wheels resource does not meet increased operating requirements. The current trend in increasing the train's speed and increased loads leads to growth of tension in contact of rail wheels and rails. This inevitably is accompanied by significant wear of contacting surfaces, which is a major cause of premature replacement of wheels and rails. Long-term analysis of the wheels and track on the railways of Ukraine shows that during the operation, the rolling surface's hardness of the wheel and surface hardness of the non-heat-treated rail increases from 270 to 400 Brunel to a depth of 5 mm. This occurs as a result of cold hammering of metal surface layers. At the same time, the surface hardness of the wheel flange and lateral portion of non-tempered rail remains unchanged, 270 to 280 Brunel. That is why, in the contact area of the wheel flange and lateral working head of the rail, an increased surface wear is observed. This carries necessity to gradual machining of wheels and ultimately to their premature replacement. Another important factor influencing the wear is the friction in the wheel and rail contact zone, which occurs under conditions of wheel sliding in curves. With the high friction between the wheel flange and the lateral working face of the railhead, significantly increases fuel consumption for hauling operations, increases the wear of wheel flanges, and in some cases there is danger of derailing of wagons. The most common technique of decreasing of coefficient of friction is the use of traveling lubricant pumps. They are used for forest rails and wheel flanges lubrication. However, they are extremely unreliable in operation and do not provide sufficient effect. This technology is particularly ineffective in conditions of rolling stock operation in the highlands. Grease inevitably falls on the tread surface, which causes slippage effect. To eliminate this effect uphill and downhill, it is required to pour sand on the rails, causing a natural converse effect, accelerated wear of rails and wheels. As a mean of wheel-rail complex problem solution, attempts were undertaken to apply low-friction coatings on the lateral surface of the railhead by gas thermal method. This solution had certain advantages, but insufficient mechanical strength of adhesion to the substrate causes the coating stripping off in a very short term. Therefore, this trend can be regarded as a dead end. As practice shows, the ideal solution of the wheel-rail complex problems can be obtained through increase of the surface hardness of the working areas of rails and wheels, selection of the optimal ratio of these values, reduction of the coefficient of friction in the contact zone. We have essentially proved that the wheel flanges hardening to a high hardness becomes an effective way of lateral wear control of both wheel flanges and rails. Similar conclusions were reached by Swedish and German experts. They offer solution which performs melting of surface by laser and application of 2 mm wide strip of cemented carbide alloy on it. It is expected that this technology slows down the wear of wheels by 4 times, while reducing wear of rails and the noise level. These figures are questionable, given that the bandwidth of hardening strip is 2 mm only. In addition, this technology has a number of disadvantages. It is quite complicated in implementation and requires highly skilled personnel. The practice of using argon plasma hardening method, developed by Russian specialists as well as HFC in Poland, also not widely used because of the presence of significant deficiencies, which include low depth of surface hardening, low productivity and high probability of defect formation, depending on environmental conditions. The development we offer has a number of significant advantages, and at the moment can be considered as the most effective means of the rail wheel complex problem solution of wage wheels flanges and working part of the rail head surface. The unit includes: first, source of energy; second, control equipment consisting of 3 units; third, computer module; fourth, 2 forming modules with cable hose spec up to 8 meters long; fifth, autonomous cooling unit. Basic unit can be supplied without the computer module. On the basis of the unit, developed a new technology of slid flat release on the rolling surface. Equipment and technology are patented in Ukraine, Russia, Kazakhstan and China. After long-term run test of hardened wage wheels on the test railway routes of Dnipropetrovsk Institute of Transport Engineers, the first set of equipment was installed at the Znamenka locomotive depot. Since 1996, the railroad depot carries out locomotive wage wheels flanges hardening directly under the locomotives. In 1996, our equipment was installed in the locomotive depot Lviv Zahid as well. In 2000, in this depot was installed modified unit with computer module. In locomotive depot Krasny Liman, the equipment was installed in 2012. Our solution has the following indisputable advantages: cost effectiveness. The cost price of one wage wheel hardening is only $23. In Ukraine, the annual economic effect is from $800,000 to $1.5 million per one railroad depot. High speed of the process. One wheel hardening takes 5 minutes only. Ease of operation. No need of highly skilled service personnel and no complex procedures. High reliability of equipment, which is proved by long-term successful operation in Ukraine, Moldova, and the Baltic countries. Independence from environmental conditions. The equipment produces no defects even at operation in open conditions at a temperature from -10 to +40 degrees Celsius. Process versatility. The equipment can be used both for hardening of both wheels flanges and the rail heads hardening. Only our equipment is capable to carry out hardening of the rail working head directly on the railways and in outdoor conditions. After wheel flange and working rail head hardening, the coefficient of friction reduces by 40%. Technologies and equipment offered by us are versatile, effective, and cost-effective solution of the rail wheel complex problems, have a number of advantages as compared with other methods, and are of interest for all railways in the world. At the moment, we have produced and installed more than 30 sets of equipment for wage wheels hardening. Hardening of locomotives, passenger and freight wagons, and suburban electric trains is carried out. Unique experience of the formation of optimal hardening structures has been accumulated. Our equipment and technology are certified in Ukraine, Moldova and the Baltic countries and provide high resistance to cracking in the range of surface hardness in the range of 300 to 600 Brinell. Only our equipment and technology ensures repeatability of the optimal structure of the wheel flange hardened zone in the range of ambient temperature variation from -10 to +40 degrees Celsius. Wear intensity of wedge wheels hardened with the use of our technology decreases by 2.53 times. Only our solution allows hardening of working railhead in an outdoor environment and directly on the rail. Only our solution decreases wheel-to-rail coefficient of friction by 40%. Even today, we are ready to solve a number of issues of rail-wheel complex problems through manufacture of universal equipment for hardening of wheel flange and working railhead.